Please have a welcome for him with warm applause. He will give you an insight on use cases. Please, your stage.
Thank you. I don't know what's wrong with the presentation. It's just going off when I start. Great start.
Okay, I'm doing your presentation.
Yeah. Great, thank you. The color is a little bit weird. Let's try it again. So, I'm sorry. Yeah, thank you for attending this talk. And yeah, I will show you some use cases that we see in semantics in the field of e-commerce. My name is Christian Opitz. I am head of business development and innovation at Netresearch. And prior to that, I've been working as project manager, developer, designer, yeah, boy for everything more or less, since 2007. And since 2011, I'm working at Netresearch, which is yeah, basically agency specialized in content management and e-commerce. We're in Leipzig, and the company was founded in 1998. And we serve global companies in building their web platforms and shops and stuff. Like, for instance, AIDA is one of our bigger customers. And we are very proud that yesterday one of our bigger projects with this customer was in the video, this guest portal stuff on the ships. Besides that, we also develop and maintain third-party integrations for mainly Magento, so for payment and shipping providers, basically. Also, since a year or so, we are part of a project that is called LEDS. And this means Linked Enterprise Data Services. This is a 3-year project funded by a federal ministry in Germany. And its goals are the integration and management of background knowledge and yeah, coming from enterprise and open data, and also monitoring the access to this data and its quality, and providing some kind of versioning and evolution of this data, analyzing unstructured text and getting structured data out of this unstructured text, and also scalable and topic-oriented search is part of this project. The results are regularly applied in the domains of e-commerce and government by some of the 4 industry partners, which are all situated in Leipzig, and 2 research partners, the University of Leipzig and Technical University of Chemnitz. So before I jump into the use cases, I try to give you a very rough overview about what we mean with semantics. And I picked out like 2 terms that seem important to me. I won't get too technical at this point. There's a lot more to read about this, but I think it's not the right place for me to show you about that. So one term that is very important is the semantic web. That is coined by Tim Berners-Lee already in 2001. And it's basically an extension of the World Wide Web, as you know it, but for data that can be processed by machines. And it's based on common, and that's important, structured data formats that are also standardized by the W3C consortium. Most fundamentally, there's the RDF format. Yeah. Since then, in 2001, it was quite rarely implemented. But lately, thanks probably also to initiatives by Google or other search engine providers, it is more and more evolving because it's getting more important that your data on your website is exposed to machines and not only humans. The other term is linked data, which is also coined by Tim Berners-Lee, but this time in 2006, in combination with the semantic web. And this term covers a method or more methods for publishing structured data and giving opportunities to search them better and to interlink the data. So it reuses technologies that are already there, like the HTTP protocol and RDF and URIs. And it structures data into entities, which can belong to certain vocabularies, like, for instance, there are product vocabularies or personal vocabularies or institutional and so on. Even stem cell crows describing vocabularies are available. And they can have relations between each other. And always when there's some relation between them, they are defined by the URI of this of the target. There is already a big crowd of open available data, mainly created by universities and governments, which you can just use freely. And this looked in 2014 like this, and I guess it's even a little bit more since then. Okay, so just this as a short introduction into the topic. Our first steps inside the LEDS project that I just mentioned was to actually find use cases for what we can do inside e-commerce with this big toolkit, so to say. And the first one that we picked out is in business data integration, where we see currently the problem that we have mostly multiple applications which all belong to a specific domain and cover specific use cases. Like, for instance, you usually have an enterprise resource planning system which holds basic product information, stock data, and so on. You have shop systems which actually display the products to the users and handle the checkout and stuff. And you have content management systems, as you all know, and you can have customer relationship management system. If your shop system and the management of product information there isn't enough for you, then you usually can use also a product information management system where you can, on top of the information for the web, manage information for instance, printed catalogs or social media channels and so on. And last but not least, you have usually some digital asset management system where, yes, all your files and stuff are stored. Usually the data between these systems has to be exchanged in some way, and mostly this happens by business rules that lay below. Like, for instance, the product information management system requires basic product information from the ERP, and the shop requires the information from the PIM, and the ERP needs to know when there was actually an order inside the shop system, and the CRM needs to know that, and the CRM needs the customer data and stuff and stuff and that. So what you see in the resulting is a lot of connections that have to be established, and in real life you often have more complex business rules that have to be fulfilled somehow. And the main problem that we have to deal with every day is that the code is, or the formats and the services are mostly vendor specific, so we have to somehow transform them and get them into different formats. Today this is solved by either wiring the applications directly, so you have for each system that you need to connect or that needs to connect another system, you have to have some adapter or connector, usually by extension or module, or however it's called within the system. And it's getting quite costly when there's no such adapter available, because you usually have to develop this on your own. And also you have further dependencies between the systems, because the adapters usually know how to work with this version of one system, and they have a dependency on the system where they are running and stuff. So it's getting really complicated and is hindering you actually upgrading your complete application stack. And also it's usually inflexible, because you have to, when you have another system or you have another business rule to implement, you have to usually do changes in other systems or in a lot of systems. Another approach to that is using some middleware, where's actually two kinds or two main kinds that I see. It's ETL, that stands for extract, transform, and load, which does exactly this. And it's mainly there for handling big amounts of data. And also there's the ESB, it's Enterprise Service Bus, that is handling, is doing quite the same, but is handling transitional data or transactional data, so more or less real time. There are affordable solutions out there, like for instance from Talent or Pentaho or MuleSoft. They are mostly free in the first run, but you have usually a lot of time or money to invest to get them actually running, because it's always a steep learning curve to get into those systems, and also there's not too much good receipts to get in there, because this is not an open source world as we know it from Typo 3 or Magento or stuff. But these are, the sources for that are mostly not that open. Also, you have the problem that you usually transform formats, for instance, some CSV exports. You have to transform them from the source to the target, and you usually do this directly because there's no, in the first run, no sense to do other. But then with this, you have further dependency, or you just reintroduce the dependencies that you had with the directly wiring applications. How are we gonna solve this with with semantics is moving the actual domain-specific data into a data lake that we call enterprise data lake, which is now holding a representation of the data in each system, but in semantic and structured data. This allows you to use the linked data technology stack to put in your data and to read it out. And you can, I told you, you have the ability to link all the data, and you can also read out from any domain. So basically you have a query language, what you see here. well, however, the gray lines that are down at the green bubbles, they should show semantic queries like SQL, more or less, and not direct integration. So you can read out from anywhere and just write it back. And the transformation between the interfaces that the systems like the shop and CMS and so on actually deliver, and this data lake is done, or we plan to do this with ESB or ETL middleware. So with this we solved some problems that we have with the usual data integration, like we have a reduced vendor and application dependency, because we can actually replace each of the system as soon as its data is reflected in the data lake, and exchange or split it into more systems and however. So it's quite good or quite flexible as well. And also you see at the bottom right of the data lake there's a little box that's BI. This is business intelligence. So the query language allows you to retrieve data from all your domains. So you can use business intelligence software to gain insights that you usually couldn't ever think of, because until now, at least for us, all the data was somewhere locked within the systems. Now they are all in one place and we can drive analytics about it. Also on the left you see two applications that I will show you into further use cases. That's the CA, that's content augmentation, which augments data from this lake, and master data management, which actually helps you creating it. Okay, another use case that I just mentioned now is this is content augmentation. There it's about that writing and updating and linking editorial content is quite time consuming, and also getting content out to the world is crucial, mostly for a lot of fields, but especially in e-commerce, because you have you need it to be good quality, you need it in a good amount, and you need it quick. And also the regular publishing of your content to social networks and to react on the feedback and so on is also costs a lot of effort. And how we gonna solve this is using background knowledge, like for instance from the linked open data, the big ellipse that I just showed you, for at least editor's assistance. This means when you imagine an editor writing in his text field, then he will be presented with the entities for that background knowledge was found somewhere, like for instance the DBpedia, which is like a data representation of Wikipedia. And here, for instance, it's some toy car reseller who is selling a bundle of two Aston Martin models, and here he has the choice. It's presented with the background knowledge for James Bond, which he can then choose to include into parts of the page. We could think about, for instance, including it to the footer, but also including it into some paragraphs, into parts of the sentence and stuff, and also we could think about paraphrasing the actual source so that it's not exactly the wording that's written here. We could also think about doing this automatically based on certain rules, where you could for instance, define a vocabulary from which you always want to include contents and where you want to include them. And the next point that we're thinking about to solve with this, also with background knowledge, is to match the contents that you actually have in your publishing system with the trending topics on, like, for instance, Twitter, and to at least say automatically to your editors, hey, there's something trending where you also have relating topics. Might you think about posting something? And the next step would be to actually really automatically posting something. But I think the world will show if that's actually really a good idea to really automatically post stuff out. And so what to get out of this is basically that you have reduced your efforts in editing, and you have easier editing workflow by getting additional contents onto the site. You also keep your users, or you have the chance to keep your users on the site by keeping them reading. And the main goal is also to gain visibility in search engines and reduce your social media management efforts and increase your coverage of social media networks at all. Another use case that I showed you on the data lake is what we call master data management. It's quite an ambivalent term. What we mean by this is that when you think about the conception and modeling of your product data, you have to do a lot of work and a lot of thinking upfront. Because you have to think about product categorization, so how do you shape your categories, where put you which products inside, how do you link them, like for instance for cross-selling, upselling, how do you define the attributes, you have to decide on the type of attributes, which might be quite easy, but you have to also configure enumerations, like colors and validations and so on. And also you have to classify, usually you have to classify your products, and this can be a really time-consuming process, which that's the other problem, requires not only knowledge from like the product manager, but also from content management, from the marketing and editorial knowledge is required as well. And from the particular field, from where is the product actually. And when you do something wrong there, it may cost you visibility, and also you might have, or changes might be hard to correct. Our idea how to solve this is to use existing product data that is out there in the semantic web, based on, like for instance, the product title or the SKU. So you type your basic product information in some field, and there is a data set out there in the semantic web that is containing information about the actual websites and which semantic information they contain. And it's a good idea for you to, for you as webmaster or shop provider, to publish semantic data to the web, because it's actually used by Google, for instance, for their rich snippets and stuff. So what we could do there is to reuse the information that's already on the web to decrease the effort that you have in the conception of your product data. And as well, when you just formed and concepted all your product data once, but maybe it changes, and maybe also the competitors change their product data, and you have to cope with that, you have to keep up with that. How do you know? You have to have someone who's constantly looking out in the web if there's something changes. It's his ear on the market, and this could be automated a little bit in this way that you regularly research the web for changing information. So what you, or a shop provider could get out of this is that he has, of course, reduced product management effort, and he could have a quicker time to market, and also you could have actually an eye on the market and yeah, be up to date with it. Another field that is in another field of semantics that's already covered quite a lot, but it's however an important topic, is semantic search, where we deal with the problem that usually when you search for terms that are not actually in the index, you will not get results unless someone sat there and actually added keywords because he knew someone is going to search for this. An example would be if there is a toy car reseller who is selling corgi cars, or imagine Siku in Germany, that's quite a good toy car reseller or manufacturer. And now a customer is going to his website and searching for Matchbox. Naturally, the system could not know that a corgi car is what he is meaning by Matchbox, because the term is quite used for you. You say Matchbox for little cars. And what we could do with semantics is invoke background knowledge to match it with that what was actually searched. So we would gather background knowledge for the term that was searched, as well as for the contents that are inside the index, and then use it to match it. On the example that I just gave, it would be that the process would find out that Matchbox somehow relates to toy cars, and it would know that corgi cars are toy cars as well, and could then present the user for his search for Matchbox actually the corgi cars of the vendor. So the benefits are quite clearly that you could have better search results. You don't need to manually provide additional keywords, so it's basically an automation as well. And also, when you're thinking about the data lake that I showed you in the prior use case, you can reuse data from actually any field that you have inside this lake. A quite similar use case is for recommendations. It's what's called usually the recommendation engine, where you want to provide your web shop visitors related products or related articles, which is often referred to as up or cross-selling. And you can do this by either manually linking the products, which is very time-consuming. Also, it's quite prone to errors. And it's inflexible because changing the relations between the products is quite time-consuming as well. And the other way to do this is to use more or less sophisticated algorithms, which are either not giving you the results that you actually wanted, or are extensive to implement, or are expensive because they come from vendors that are specialized in this and want the resulting prices from you. The solution with Semantics is more or less related to the semantic search as well. You can use the background knowledge to establish relations between products, and also you could, when you once again think of the data lake that I showed you, you could also implement data from other systems, like for instance the CRM system or from the ERP, and do probably funny stuff with that. Benefits, I think, are quite clear, that you don't need to do this manually, and you don't have to implement custom algorithms or to use expensive existing ones. To summarize this, our main and most important use case that we really see is the business data integration, because this just enables the other use cases, because when all the data is inside the data lake, we can use more or less any kind of applications that work with the data inside it. So you can imagine, like, when you're on the data lake, there's some fishermen or some boat shipping above it and doing something with the data inside. And within the LLDS project, the scope is mainly to build a stack that is using all the tools that are out there already, like Hadoop and Sparkule stuff and so on. Excuse me, at this point I'm not too techy. However, they are connecting them for a toolbox that is just starting out of the box without too much installation efforts and so on. However, the other use cases are quite important for us as well, but as I said, this is for us the main target to reach within this project. However, we were thinking about these use cases, and we're in a quite isolated scope with that. Of course, we're talking with our customers about it, we're talking with other people about it, and are getting reactions and so on. And this is where I would love if some of you could give me some feedback, yes, by mail or by phone, or if you want, by fax, or snail mail if you want to. And yeah, thank you a lot, and I'm open for questions.
Thank you, Christian. That's your part on clapping, actually. Okay.